So good day everyone, I'm January Bransobel and I will be presenting the decision trees from engineering management subject. So for our background, any problem that can be presented in a decision table can also be graphically illustrated in a decision tree. All decision trees are similar that they contain decision nodes or decision points and state of nature nodes or state of nature points. A decision node from which one of several alternatives may be chosen, plus a state of nature node out of which one state of nature will occur. So when we say decision trees in our daily lives, it is very crucial in us for our decision making because it takes time to select the better option. So in this topic, there is a visual guide for us in our decision making. So for the next slide, 5 steps of decision tree analysis. First is define the problem, structure or draw the decision tree, assign probabilities to the state of nature, and last estimate payoffs for each possible combination of alternatives and state of nature. So next we have example. John decides whether to construct a large plant, a small plant, or no plant. Then once that the decision is made, the possible state of nature or outcomes, either favorable or unfavorable market, will occur. The next step is to put the payoffs and probabilities on the tree and begin the analysis. So Thomson's decision tree. So as you can see to our figure, a decision node is the first the problem, and we have the line segment for the node. We have construct large plant, construct small plant, and do nothing. So to our state of nature node, we have possible outcome, the favorable market and unfavorable market, the same as the small plant and do nothing. Next is larger decision tree with payoffs and probabilities for Thomson lumber. So if we compare to the previous slide, so this is the expanded version of our decision tree. So as you can see, there is the first decision point, which is conduct market study and do not conduct market study. However, the second decision point is the large plant, small plant, and do nothing. So for our line segment or the node, state of nature node, is the favorable market and unfavorable market. So there is the possible outcome or the probability and then the payoffs. So next, computing the EMV of each branch. So the EMV stands for expected monetary value. So first, given favorable survey results, EMV from node 2. So all we have to do is to sum up. First is to multiply the probability times the corresponding payoffs and sum up to the corresponding positive survey. So for node 2 we have $106,400. So for node 3 we have $63,600. So for number 2, give it negative results, negative survey results. So from survey results that has negative is we have negative $87,400 in negative sign. Then next is the node 5, we have 2,400. So all we have to do is to select the the larger payoff for each branch or for each state of nature node. So for the next slide, the EMV calculation. So this is the continuation. So for number 3, we have EMV $49,200. So for the number 4, the market survey is not conducted. We have $10,000 for node 6 and $40,000 for node 7. So for the next slide, the Thomson's decision tree with EMVs shown. So as you can see here, there are two parallel lines that cross the line of the decision node. So as you can see, the purpose of that is to neglect the option that are not needed. Therefore, the other remaining is we have to choose. So for the number 5, so here we can see that the EMV conducting the survey is $49,200. So for EMV of 40,000 is not for conducting the study. So the best choice is to seek marketing information if the survey results are favorable. John should construct a large plant, but if the research is negative, John should construct a small plant. So for our next slide, we have expected value of sample information. One way of measuring the value of market information is to compute the expected value of sample information, or what we call the EVSI, which is the increase in expected value resulting from the sample information. So we have here the formula. EVSI is equal to EV with SI plus cost minus EV without SI. So when we say EVSI, the expected value of sample information, while EV with SI is expected value with sample information. At the same time, EV without SI is the expected value without sample information. So in John's case, EVSI is equal to $49,200 plus $10,000 minus $40,000. So we have $19,200. This means that John could have paid up to $19,200 for a market study and still come out ahead. So when we say the $19,200, it is the amount paid for market study. So next, the efficiency of sample information. While none of these sources of information are perfect, they can evaluate it by comparing the EVSI with the EVPI. If the sample information was perfect, then the efficiency would be 100%. So as you can see, if we evaluate the efficiency of sample information for Thomson lumber example, so we have 32,000. Therefore, the market survey is only 32%. I mean 32% for the efficiency of sample information. So the market study is only 32% as efficient as perfect information. For our next slide is the sensitivity analysis. So sensitivity analysis for decision trees assesses how changes in key variables such as probabilities or financial payoffs affect the optimal decision or the overall expected value of the decision tree. So that is the sensitivity analysis. For the Bayesian analysis, The Bayes theorem approach recognizes that a decision maker does not know with certainty what state of nature will occur. It allows the manager to revise his or her initial or prior probability assessments based on the new information. The revised probabilities are called posterior probabilities. So in Bayes theorem or Bayesian analysis, whether you conclude that you will select the better option by doing the probability and payoffs, so also you have to verify or make an probability assessment for the new information. So we have here the formula of Bayesian analysis. So as you can see, the posterior probability. So this is the posterior probability. So example, market survey, reliability in predicting state of nature. So for probability revisions given a positive survey, so as you can see here, the probability survey results positive is 0.45. So if we compute the posterior probability, so we have 0.78 for FM. Then for 0.22 is for posterior probability of UM, stands for unfavorable market, and FM stands for favorable market. So our interpretation here is, if the survey is positive, the probability of a favorable market increases from 50% to 78%. So next, so in this probability revisions given a negative survey, so as you can see, the posterior probability of of FM and posterior probability of UM is inversely, or it is reverse from the positive survey. So therefore, if the survey is negative, the probability of a favorable market decreases from 50% to 27%. So the advantage of Bayes analysis, it is used to help determine the correct conditional probability that are needed to solve these types of decision theory problems. So thank you, and that's all.